All right. Here we go. Now we got a couple of sketches to do that don't really have any, there's none of this limit stuff. So let's see what we've got here. Take a look at problem 4. What'd you say?
We got a hole.
Chuck says we have a hole. Let's look at it and see.
We have a hole.
We're going to graph x squared minus 9 over 3x plus 9. So the first thing we do is factor, right? We did that before. We're going to factor. And how does the top factor?
X plus 3, x minus 3.
Plus 3 minus 3, good. And how does the bottom factor?
3.
Take a 3 out.
X plus 3.
Uh-oh. Now we have something that will cancel.
So we have no vertical.
The formal, one step at a time. The formal name for this is a removable discontinuity. But we can think of it as a hole. Because in the graph, there is just somewhere, there's going to be this open dot somewhere in the picture. So first thing you have to do is figure out where that is. The factor that canceled out provides us with our x coordinate. So since we canceled out x plus 3, we're going to have a hole at -3, right? And then how do we find the y? Plug it in right here. Right here. So -3 minus 3 over 3. I got -2. What about you?
Yeah. Wait, can you explain that one more time?
-3 minus 3 is -6. Divided by 3. It's what canceled out. Right? Okay. So -3, -2. There is my hole. Now, after that, everything else is the same. Now, somebody has already pointed out that there are no vertical asymptotes. How come? There's no x in the denominator. Right. How do we get vertical asymptotes? We have a 0 down there, and we can't get a 0 down there. Okay, so there's no verticals. What about horizontals? Well, there's none of those either because there's no x in the bottom. So there's no asymptotes. Okay. How about a y-intercept? What happens if I let x be 0?
It's -1.
I get -1. And what happens if I let my numerator equal 0? What would make this 0? 3. What in the world?
It's a linear line.
It's a linear line. Yeah, lines are linear. It is a line with a hole in the middle of it. That is exactly right. Now, before you start getting all confused, this is what we graphed, right? After we canceled, this is what we graphed. Another way of writing that is y equals 1/3 x minus 1. Y equals mx plus b. So your y-intercept was -1 and your slope was 1/3. Up 1 over 3, down 1 over 3. See that? All the pieces came together. So we didn't end up with any of this stuff, any of these arcs, because we didn't end up with the denominator. All right. And that was okay. Let's see what happens with this next one. See what happens So how does the top factor?
Mine, x plus 10, x minus 5.
I would suggest, most of you guys are decent factorers, but I would suggest that you always check, because if you mess up your factoring, think about what that's gonna do to your problem. It's gonna put your asymptotes in the wrong place, it's gonna put your intercepts in the wrong place, so you don't want that to happen. So is this the correct factorization? Foil it back. Does that give me that? Yep. Right? How about my bottom?
You got 5, and x squared minus 1.
And x squared minus 1 will be x minus 1, x plus 1? So now I am completely factored. Would you agree with that?
Yes.
What sweatshirt is that? What collar is that? Who are the freaks? Guess what?
Yeah, take that off.
And we're language underneath freaks, okay? But that is not a uniform sweatshirt. And freaks, you guys are called the freaks?
So weird language.
That's
Weird running back name, okay, whatever. All right, so we got a cancellation, right? Got a hold? So let's look at what we have left. This is what we're going to graph. Now, this is what happens more often than what just happened. In the problem we just did, we lost our denominator altogether, and so we ended up with no asymptote. But that's not what's gonna happen here. I'm gonna have some asymptotes in this problem. Is everyone with me to this point? Okay, so we know we're gonna have a hole. Let's go ahead and put it in the picture. What is going to be my x coordinate of my hole? -1. How will I find my y? I'll plug in -1, so that's gonna be -1 minus 5, -6, over 5 times -2. So 6 over 10, which is 3 over 5. So, -1, 3/5. Now, tell me what else you can tell from here. What else can I see that I have?
Your horizontal is 1 over 5.
My horizontal is 1/5, which, I'll do it here in blue, is under that hole. Would you agree with that? So there's 1/5. Remember, the hole was at 3/5, so 1/5 is under it. That's my horizontal. 1 over 5. All right, what else do I have? A vertical, where? 1. Okay. What else? X-intercept will be at 5. Pictures starting to come together. How about a y-intercept? How do I find it?
It's 1.
I put in 0, so I'm gonna get -5 on the top and 5 times -1. Do I get 1?
Oh, rather that.
The rabbi.
Oh.
Where you talked about
That
it.
Joe called it out.
Yeah, definitely.
Yeah, you did.
Cut it out, dude.
If I did that on purpose, I'm not talking.
How about this?
Yeah, you would totally do that.
Okay.
Reciprocal function, yeah. This is exactly like the ones we did earlier, except they didn't have a hole. Otherwise, it's exactly the same. Now, quick comment about your holes, your removable discontinuities. The curve goes through it, okay? You're never gonna have a picture like this and have some random hole somewhere else. Okay, that does not happen. The curve is gonna pass right through it. It's gonna be part of the curve. Okay?
I just drew that.
All right, quick question before we move on to the next one. Quick question. Limit. X approaches 1 from the left.
Positive infinity. Positive infinity.
Positive infinity. Because 1 is our asymptote. This is the left side. As I come in toward the asymptote from the left, my pencil is shooting up. So positive infinity. Very good. One more. The limit as x approaches negative infinity. It's the limit as x approaches negative infinity.
1 plus. Wait. Negative. 1 plus. It's come from the top.
But it's not 1.
Oh, it's 1/5. Oh, my God.
1/5 from the top, yep. Because in the asymptote at 1/5, so we're gonna keep getting closer to that, right? Okay, now we're ready for some action. All right, what do you wanna do with this guy? We're gonna do what we always do, we're going to factor, right? So how does the top, bottom doesn't factor, how does the top factor? X plus 1, x plus 4? So we factored, but nothing canceled, and that is perfectly okay. It simply means this picture has no holes in it. So there aren't any holes, okay, fine. Is there a vertical asymptote?
Yes.
The vertical asymptote,
X equals 2.
x equals 2. Is there an x-intercept? An x-intercept, actually there are 2 of them, -1 and -4. So -1, 2, 3, -4. Remember, x-intercepts come from the numerator. There are 2 things, 2 x's up there in the numerator, so there's going to be 2 x-intercepts. Got it? Now what about a y-intercept? What happens if I put in zeros?
5 over negative 2. 5 over negative 2.
Wait, how'd you get 5?
0 plus 1.
Wait, if I put in 0, I get 1
5 over
times 4
2.
over -2.
Yep, negative 2.
Remember, factors mean we're multiplying, right? We're not adding, we're multiplying. So what is that, -2? Now, what does this problem not have?
Horizontal.
It does not have a horizontal asymptote. Because why? What's the highest power on the top? X squared. How many x squareds do we have on the bottom? 9. So we have 1 x squared over no x squared. Can you have 1 over 0?
Nope.
No. Now, this is the new part. Horizontal asymptotes are called end behavior asymptotes. It's how the curve behaves out here at the end. End behavior asymptotes do not need to be horizontal. They will be horizontal when the powers match. So when we have like 2x squared over 3x squared, then you're going to have a horizontal asymptote at y equals 2/3, right? That's what's happened for us. When the power on top is bigger than the power on the bottom, then you have some other kind of asymptote, not a horizontal line. When the power on top is 1 bigger than the one on the bottom, which is what we have, x squared over x, you have what's called a slant asymptote.
Oh.
And our slant asymptote is going to be exactly what you think. Instead of being horizontal, it's going to be at a slant. It is very easy, you already know how, to find the slant asymptote. Let me look at the original problem before I factor. Would you agree that that is a division problem? That's a division. So I'm going to do synthetic division. What is going to go in the box? Positive 2. And then 1, 5, and 4.
You can do that on me.
I did not expect to get a 0. I will not get zeros when I divide with a slant asymptote. The remainder is not important. The remainder is not part of the problem. Tell me what this says. Remember, this was x squared. So what does that say? X plus 7. That, my friends, right there, x plus 7, that is your slant asymptote. Okay? Now, I have to graph that now. So, because I'm graphing my picture, so I'm going to erase some of this. My slant asymptote is y equals x plus 7. So tell me, what does that look like? X plus 7 is a line?
Yeah, it's line up 1 over 1.
And its y-intercept is 7?
Yeah.
Oh, yeah. Oh, I get it.
So it's exactly what we said, it's a slant. It's slanted. What in the world does this look like? These all have to be connected, okay? So let me draw something.
Parabola.
Well, yeah, Whopper drawing parabola. Does that make sense to you, that it would look something like that?
So that's the parabola.
But we're not done. How many pieces do we have to have? 2. What'd you say? Elijah says right here is the other piece, and he's exactly right. Now, this goes back to what we talked about earlier. You have to draw something on the left side of your page, or right side of your page. You have to draw something over here. It has to approach the asymptotes. In other words, whatever you draw, it's going to get closer to the asymptote, okay? If you tried to draw it down here, you can draw something down there, but what happens right here? Can't do it, can't cross it. So therefore, it can't be the bottom piece, So it has to be the top piece. Okay, all right, deep breath. Here we go, one more.
What?
Stop.
Yeah, Aiden. That was you, Aiden. That was all Aiden right there.
All right, here we go. Can you tell? I'm listening to Elijah up here. He participates. He says, first, let's just find the slant asymptote. All right, now wait, that's fine. Does everybody recognize we're going to have a slant asymptote?
Wait, can you tell me why?
Somebody tell him, because he wasn't paying
X
attention.
squared, we've got more.
We have a power on top
And not a power.
that's one bigger than the power on the bottom.
It has to be one bigger.
Has to be one bigger.
That's it.
If it's two bigger, then your asymptote is a parabola.
Oh, wow.
Is that power
So
what?
your asymptote, guys, your asymptote can be any shape in the whole wide world. If you had a parabolic asymptote, so if you had an asymptote that was a parabola, and maybe a vertical asymptote like this, then the curve would look like this.
Are we gonna get into this?
No. But he asked the question, so I answered it. We have a horizontal asymptote when we have x over x, x squared over x squared, something like that. If we have x squared over x, or x cubed over x squared, we're gonna have a slant asymptote. And Elijah said, let's find it. We find it by dividing what goes in the box. -2. That's fine. That's fine. We have no issues. This is wonderful news. Remember, that doesn't count. So what's this equation? Y equals x plus 0. Y equals x, which is a super simple line to graph. This is y equals x plus 0. All right, let's put the rest of it in. What else do we have? We have a vertical asymptote at x equals -2. Might want to factor the top. Is it +3 - 1? Which means we have x intercepts at -3 and +1. How about a y-intercept? What is my y-intercept? -3/2. And we don't have any holes? Right? Okay, this is it. Figure out what it looks like. Take a second. Connect your dots. See if you can figure out what it looks like. Right here. Do you see that? What about the other half? That's the right side. The left side, you got a point right here, right? You got a point. So it's gonna look like that. right, here's the good news. Homework 2.6 is due on Friday. 2.6 is due on Friday. The even better news is you have 5 minutes.
Yes.
And you can start 2.6 right now with your teammate.
What happened?